Cool. Well, thank you everybody for joining us today. We're going to be talking about site reliability engineering and how you can build a culture of site reliability in your organization. Let's go ahead and I know Q kind of introduced us, but I'm Brian Love and the co-founder of Polaris. And go ahead, Mike.
Yeah, and my name is Mike Ryan. I'm also a co-founder of Polaris.
Okay, so what Mike and I have been realizing is we've worked with a lot of organizations and we help them with site architecture and site reliability, and we've been doing this for years. And in general, we have found that most organizations are in one of three groups. First, some organizations basically just have no focus on site reliability. They don't really have any resources or maybe even the requirements to invest in reliability. And so simply put, they just kind of shrugged at reliability. Second, we found that there are a few select organizations that have gone through the fire of site reliability hell. They struggled for months, maybe even years, to build a culture of reliability. They learned through trial and error and have built systems and procedures to ensure the reliability of their systems. And then third, we learned that many organizations are stuck in an endless loop of triaging and pushing hotfixes. These organizations are pretty acutely aware of their need for site reliability. Shockingly, we found that some of these organizations even commit to what are called service level agreements, or SLAs, which are a legal binding contract that guarantees a level of availability of their service. Perhaps even scarier, though, is that some of these organizations, they don't even measure or monitor their service availability that they're legally bound to provide. So we came to the conclusion that most organizations, they kind of rely on a strategy of hope. But the reality is that hope is not a strategy. Now, maybe you've heard this before because this is kind of the main mantra for SREs. And this comes from the Google Site Reliability Engineering book. I like it. I think it captures the essence of site reliability in most companies where hope is the strategy. While we kind of dive into this, let me kind of introduce a few myths around site reliability engineering, just so we can kind of get those out of the way. And then we'll talk about how to build a culture of site reliability in your organization. One of the first myths that we learned is that it's common to believe that the metrics that are required for measuring reliability can be gathered on the back end through things like server logs. But the reality is that not all behaviors can be collected on the back end. A few examples of these might be things like latency or degrading API performance and core web vitals. Second, the next myth is that user experience is perceived to be aligned with the performance of the back end. So if your back end is doing well and your logs are looking good, then the performance for your web app is great. Your users are getting that same experience. But as UI engineers, we know that this is not the case. UX includes runtime performance, runtime exceptions, and there's a lot that happens between the user's browser and your server. The third myth that we want to briefly mention here is that the reliability of a system can be measured in uptime versus unplanned downtime. However, today with distributed systems and distributed users, time-based availability just doesn't accurately capture the true availability of a system. Fourth, Fourth, our number goal is to build 100% reliable systems. And the reality is that this is just stupid. The greater the reliability target of a service, the greater the cost to engineer that service. So beyond a certain threshold, there's basically diminishing returns for increased reliability of a service. Fifth, the pace of innovation in your organization should not be inhibited by the reliability of the systems. This is also not true. And we know that innovation is at odds with reliability. To move fast, we may and often do break things. We need to work with stakeholders to strike a balance between innovation and stability. So what do? We need to embrace risk in our organizations, but we also need to build an organization around a culture of reliability. We're constantly pushing new features and building better products. While embracing risk, we must have observability into the reliability of these systems that we're building. And we're going to do that with three main strategies. One, we want to define the desired availability for our system. Two, we need to build a culture of reliability through measuring and monitoring the reliability of our systems. And three, we have to have a plan for failure. Okay, let's break those down and we'll talk about each of those. First, we want to define the availability of our services. In order to do this, you might want to ask yourself some questions like, what level of availability do users expect? Does availability affect revenue or reputation? What level of availability are your competitors providing? And is the service consumer-facing or perhaps enterprise-facing? You've probably seen a chart like this in the past where it has like the number of nines and the downtime allowed per year per month. But let's also add in kind of potential revenue loss as well as costs. So if we determine that the level of availability that's required for our system is extremely high, or 5 nines, then our system should only experience about 5.5 minutes of unplanned downtime per year. Obviously, we need to balance revenue or perhaps reputation with the cost to achieve that level of availability. Keep in mind that costs not only include engineering time, but also think of things like redundancy and opportunity costs. Let me give you an example. If we determine that the level of ability, hold on, next slide. There it goes. That was a long delay. Let me give you an example here. So if our application is generating, let's say $1 million in revenue, and we're already achieving 3 nines of availability, then in order to increase from 3 nines to 4 nines, that needs to provide us a $900 value. So not a lot, right? So if the cost is less than $900, then sure, we should go ahead and invest in increasing the reliability of our systems. If it's more than $900, then we probably don't need to invest in going from 3 nines to 4 nine on this particular application. So what we want to do is we want to build a culture of reliability. And how are we going to do that? The first thing that we do is we're going to define what are called service level indicators, or SLIs. And then those will be rolled up into what are called service level objectives, or SLOs. And then perhaps if our organization requires it, we can have SLAs, or service level agreements. Okay, so let's talk about service level indicators, or we can just call these indicators if that's easier, probably not such a mouthful. So indicators are carefully defined quantitative measurements of some aspect of the level of service that is provided. Examples of these can be things like failure rate, latency, maybe largest contentful paint, first input delay, or cumulative layout shift. To make an indicator valuable, we often need to kind of aggregate these, and we're going to aggregate them based on some sort of time interval, maybe the last 5 minutes or maybe the last hour. And then we want to identify the frequency of measurement. How often are we going to actually measure these indicators? And potentially we want to filter these indicators based on the service, geography, or region. So you may be only concerned about people with a 4G connection quality that are located in North America or something like that. Okay, let's take a look. Here's an example SLI. Here, we're measuring the mean failure rate in a 1-minute window. We're going to measure that every 10 minutes, and we're going to filter that down to North America with a 4G connection quality. So now that we have this indicator, we're going to roll that up, and we're going to create what's called an objective. And an objective is established by the stakeholders of our system, and they help us to determine the internal, so not external, the internal reliability of our system on a quarterly basis. The stakeholders are responsible for monitoring these objectives to ensure that the team is meeting these objectives, and we can take corrective action before it's too late. If we start to see that we're approaching a lower bound or something like this around our latency for a particular API request, now that we have observability into knowing about that, we can start to address what's going on, and we can start to balance that innovation with our reliability. Finally, I did mention SLAs, or service level agreements. And like I mentioned earlier, these are legal contracts between your organization and your customers. It is important to note that if you do have SLAs, you want your SLOs, your objectives, to have a greater reliability of target than your SLAs. Basically, we want to kind of under promise and over deliver. This gives us a buffer, so that way when the reliability target of our system is quickly approaching the upper bounds of an SLO, we can take action. Go ahead, Mike.
Thanks, Brian. So thanks for setting down like the fundamentals for site reliability engineering. Now I want to take this into practice and some ways in which you can improve your Angular application using Polaris. So Brian and I have spent like the past couple of years talking to a variety of teams building web apps. And what we found is that for a lot of these teams, they'll eventually suffer from something that we have termed or called reliability hell. And I want to explain what reliability hell looks like. Reliability hell starts with slow loading times. So maybe some users are using your Angular application and things are a little bit slower than they used to be. Pages are taking a little bit longer to load up, workflows a little longer to execute. Things are just generally a little sluggish. But for you as a developer of this Angular application, you might not know or detect that things are slowing down for your users because they're not letting you know, right? From their perspective, things are just a little bit slower, but they're not calling you and letting you know that things have gotten slower. That is until customers start to experience some sporadic errors. Like things aren't just slow anymore, but occasionally they're seeing error messages in the app, or things are just hanging, or they're having to hit the refresh button a little bit longer. These are when your customers are starting to be impacted by poor reliability in your Angular application. And eventually what happens is your customers become so frustrated that they start calling into your customer service team saying, hey, this isn't working the way that I want it to work. It's slow, it's crashing, I'm not happy with this. And this is when you really start to find yourself in reliability hell, because now you're trying to respond to these customer events or these customer outages, and you're having to respond to them instead of building new product. And that's not great. And if the reliability continues to degrade, then you might find that your app is just frequently down. And this is like the worst case to be in. Not only are customers dissatisfied, but they can't even use the app at all because it's suffering from complete outages. And this is what we call reliability hell, where you're having to spend more time responding to bugs and customer issues than you are actually shipping a new product. But it's worse than just like slow development cycles. Apps with low reliability degrade user trust. So if you're a user of one of these Angular apps that's slow, crashing, or not always available, you're going to learn to not trust that it's going to work. Instead, you're going to be surprised when it does eventually work. And you don't want that. You want your users to trust you, to believe that the app that you have built for them is going to work and that they can get the work done using that application. So that's where Polaris comes in. We're helping Angular developers such as yourselves build apps that people trust. So for the teams that Brian and I have worked with, we've seen that it takes almost a year to crawl out of reliability hell, and it happens in 3 separate phases. The first phase is what we call skilling up. As Brian just showed, there's a lot to learn about site reliability engineering. Just at the basics, there's some jargon you have to get your hands around, like indicators, objectives, and agreements. There's also a whole discipline of engineering around reliability. And so maybe skilling up looks like reading the SRE book or attending workshops, going to ng-conf, whatever it looks like, skilling up is the first step for your engineering teams. Once you've skilled up on site reliability engineering best practices, you then need to go find some tools and techniques that are going to improve the performance and reliability of your Angular application. So maybe you're looking at some new ways to architect your app so that it's a little bit more reliable and has better performance. Or maybe you're looking at tools that are going to help you monitor the reliability and performance of your application. Whatever it looks like, there's going to be some engineering time spent just picking the right tools and processes to improve the reliability of your app. And then comes the most expensive part of this, integration. And I don't mean that it's expensive just in terms of dollars. It is. Some of these tools are really expensive. Like you could spend thousands of dollars a year on tools like Datadog. But it could also be expensive in terms of the amount of time it takes to integrate. If you're making architectural changes or you're putting in a whole new monitoring tool into your app, and engineers have to spend the time actually implementing those changes. And all of this together, from skilling up to evaluating new tools to integrating the tools you've selected, is going to consume a lot of time. And that time could be spent building new features, but instead we're spending it trying to fix our app and get out of reliability hell. So that's where Polaris comes in. That's why Brian and I are excited to build it, because we think that it's going to fundamentally change this experience for Angular developers. So using Polaris, you can measure the reliability and performance of your Angular application in real time. As real users are using your app, you're going to get real-time insight into how your app is performing. It integrates with incident response tools. So Polaris is going to let you know when your Angular app is experiencing degraded performance or reliability, and it can notify an incident response tool of your choice in real time. And finally, we think it's the easiest tool to integrate in terms of reliability and performance because we're fully AI integrated. That means it's going to make integration a snap for your Angular team. So to get started with Polaris, first you just run npx atkit-polaris.ai/install, and that's going to get the SDK all configured up for your Angular application. It's going to help you pick and go through a full guide on getting Polaris integrated for your application. Out of the box, with no additional code, Polaris is going to begin measuring those core web vitals. That includes largest contentful paint, first input delay, and cumulative layout shift. According to web.dev, these are the most important metrics for a highly performant Angular application. But Polaris is a lot more than just the core web vitals. Using the Polaris SDK, you can measure just about anything. So if you want to measure how long it's taking for your users to be able to complete the login process, or whether or not the login flow is even working or not, you can measure entire workflows using just a few simple APIs from the Polaris SDK. And as I mentioned, as real users are using your Angular application, the Polaris SDK is going to be collecting all these measurements and sending them to Polaris, giving you real-time insight into performance and reliability. Now, I want to mention that the Polaris SDK is tiny and non-blocking. It's like 7 kilobytes gzipped, and we stay off the main thread as much as possible. We don't want to be part of why your Angular app is slow. We want to help you be the cause to get it to be faster. So once you have all the measurements in, you can then visit the Polaris dashboard where you can inspect and view all that performance data as it streams in. But we're more than just graphs and charts. Once you have these indicators of performance being pushed into Polaris, you can define objectives on top of those indicators that are going to be computed in real time. So let's say you want to ensure that first contentful paint is happening faster than 1 second in North America for users on a phone or desktop with a 4G connection quality. You can define that objective in just straight JavaScript using the Polaris dashboard. And what Polaris will do is as that real-time data is being streamed in, it's going to calculate and see if you're passing those objectives. And if at any point your objectives begin to fail or enter a failing state, it's going to reach out via webhook to your favorite incident response tool. So maybe it wants to go create a channel in Slack, let all the engineers know that, hey, something's not quite right with the current deployed version. Or maybe you want to create an issue in Jira or start your on-call procedure with PagerDuty. All of that is possible using the Polaris webhook integration. Beyond webhooks, Polaris AI is your personal site reliability engineer. So I mentioned that we're fully AI integrated, and I think that changes the game in terms of how you integrate one of these performance and reliability tools. So first off, if you use our SDK and start measuring workflows and performance data in your application, our AI will automatically recommend indicators and objectives for you based on that data. So where other tools maybe require a lot of setup to get all configured correctly, Polaris really shortcuts and helps you get to a configured state really, really fast using this AI integration. For the objectives that it understands, it's going to give you detailed feedback on how to actually improve performance for that objective. So like it knows what first contentful paint is, and it knows some general strategies for how to improve first contentful paint in your Angular application. So if you start failing a first contentful paint objective, the Polaris AI is going to give you detailed feedback on how to improve first contentful paint in your Angular app. And of course, it's 2023. What would a good AI be if you couldn't chat directly with it? So our AI lets you chat directly with it and has an understanding of your performance data, your indicators, and your objectives so that you can have a reasonable discussion to gain insight into all of that data. So as Brian mentioned, hope is not a strategy. We don't want to improve the performance and reliability of our application by just hoping that it's going to be good. Instead, we want to do better than that. We want to measure the actual performance and reliability of our Angular apps so that we have a good understanding of how to improve it and what the experience for our customers is like. And that's what Polaris does. Polaris helps you build apps that people trust. You can learn more at getpolaris.ai. Thanks, and we'd love to take some questions.
Currently, there are no questions in the chat, but I do have some questions myself. One of the things Brian talked about earlier was like the 99% site availability. Is that just measuring like expected downtime, or is that unexpected downtime, or is it a combination of both?
Yeah, usually that's going to be unexpected downtime, right? Because sometimes you're going to have like times that you need to actually perform, whether that's a particular task. Hopefully that downtime is minimal, but yeah, that's unexpected downtime. So that's what you're aiming for.
So don't most companies want to aim for 100%, or is that just unrealistic?
It's just unrealistic, honestly. Like, I mean, even like Probably one of the most reliable websites in the world is google.com. They don't even aim for 100%. Like they're still going to have like blips, right?
Mhm.
And obviously they have like 5 nines or maybe more, where it's down for, maybe seconds or a minute or something like that crazy. But that's just really unrealistic because the engineering cost that's required to build a system that's reliable. I mean, unless you're making billions of dollars like Google, you probably don't need to architect and build a system that is 99.99% reliable. That's where you need to kind of balance, cost and kind of revenue and reputation, and kind of come together as stakeholders in your organization to determine what a desired level of availability should be for your system.
Okay. Another question that I had was, I mean, you kind of answered it later by showing your product, but is there an effective way besides using Polaris? I don't know if you want to give us any hints, but like without having some third-party tool with our Angular applications, what are some effective ways of logging and checking for those SLIs? Is it going to be just, I'm going to use, what is it, Lighthouse, or is there something better than that?
Yeah, I'll take a stab at answering that question. So there's two ways to measure performance and reliability, and one is lab measurements and the other are actual real user measurements. And there's a difference between the two. A lab measurement would be something like running Lighthouse in CI, where you're spinning up a browser, running Lighthouse against it, and collecting performance metrics. That's a great way to start collecting some actual indicators of performance in your application, but there's a problem with it. Real user scenarios are often a lot different. And so if you can measure real user performance and actually detect how it's running on real user systems, you're going to find some performance issues that you weren't really expecting. I think one of Brian and I's favorite stories is we had a client that had a mostly North American set of customers, and they had some new customers in Hawaii that were experiencing really degraded performance. And it's because they're building in the Eastern or the US East set of regions for AWS services. And so performance was just awful for all their customers in Hawaii. A lab measurement would never have caught that, but a real user measurement would have. So if you're looking for like a free or an easy way to start measuring in the real user world, obviously Polaris is a great way to start, but also some other tools that do a really good job of this would include the Firebase Performance SDK. And that's completely free. And if you're already using something like Google Analytics, is a great way to bolt on and start measuring some of that stuff for real user performance.
Okay. Another question for me is, you guys kept specifically mentioning Angular app. Is this work with other frameworks as well, or is it specifically Angular only?
Yeah, so Polaris is just JavaScript, so it's framework agnostic. So you could use it with Angular, React, Vue. We've got specific integrations with Angular, React, because it just makes it a little bit easier to kind of get started with it. But underneath the hood, it is just JavaScript. So you could use it with Laravel or WordPress, honestly, right? I mean, it's just a JavaScript SDK. As Mike mentioned, it's also super tiny and non-blocking. So yeah, putting it in your Angular app or your React app or Quick, whatever you're using, hopefully it's going to be really tiny. It's not going to impact the performance of that application, and we're not going to get in the way of any sort of main thread or network requests.
Okay. And I wouldn't be me if I didn't ask, like, can this like integrate with some other runner? If you have Cypress, can I put it in my Cypress test? Is there some plugin that you can have for that?
Yeah, so since it's a measure anything tool, in theory, anywhere where JavaScript executes, you can use the Polaris SDK to collect measurements. Now, some of the things that Polaris does out of the box in terms of measuring like core web vitals, that stuff might not work if you're using it in a non-standard environment like a Cypress test or inside of a Jest test. But in terms of ability to measure anything, I think the sky is the limit when it comes to the SDK.
That's awesome. Okay. I think indicators, you guys talked about first contentful paint. Can you change those metrics, or is first contentful paint kind of like the main guy that you want to use instead of like largest, or what's the other one? I think there's largest and there's meaningful. Like, is there another one that can you like switch those out if that's maybe I know my first contentful paint's going to be fake and I want like the largest one or something.
Absolutely. Yeah, so, and this is something we actually get into a good bit in our documentation. I think the kinds of measurements you're going to measure for your app are really going to depend on the type of app that you're building. Mm-hmm. So For example, I think first contentful paint maybe makes sense if you're building like an e-commerce app. But I don't think a lot of Angular developers are actually building e-commerce apps or these like big public facing apps. I think a lot of us are actually building like internal tools or B2B applications, apps that are hidden by a password and login or like a login form. And for those, they might not care about first contentful paint. And using Polaris, you can ignore or avoid building any kind of indicator around that metric. And so instead, if you wanted to do something like largest contentful paint, or if you wanted to measure something even more specific, like time to log in, that's possible using Polaris.
Okay. We have a question from an anonymous attendee that just asks, what framework are we talking about? But I think we were kind of we're talking about Angular, but the Polaris is the third-party tool that they're talking about. Do you have a website that people can visit that has more information about Polaris?
Yeah, you can learn more about Polaris at getpolaris.ai.
You want to throw that in the chat, Mike?
This is specifically for front-end issues that come up with SRE stuff. So this could still work in conjunction with something like, what is it that we use at JD Hunt? I don't use it very often, so I forget what it's called.
Datadog, Sentry.
Nope. And Bradley's in this chat now. He can probably tell me what it is. I forget what it's called. I don't use it very often, but it's our back-end reporting tool for the most part. We do get issues that come up through it.
Maybe like Splunk?
Nope.
No.
There's so many tools in this space.
Yeah. But it doesn't really give us real front-end logging issues. It may log Dynatrace. There we go. It'll tell us that like, hey, we have a console log or a console error that's spitting out, and we need to fix it. That's it. And then we're expected to go in and fix that issue. So does it have like you guys didn't really showcase this at all? Do you guys have like a UI that we could still go in and look, or is it going to just report via logs to the users who are using it?
Yeah, that's a great question. So I think the way Brian and I have thought about this is that when it comes to site reliability engineering, there's kind of two sides of the same coin. There's detecting an issue and there's diagnosing an issue. And for Polaris, we're choosing to instrument on the front end because we think it's the best way to detect that your customers are having some kind of issue. If we can measure what their actual experience is with the app, that's actually going to tell us a lot of things about the entire system. Like if things are slow to load, it could be because of a JavaScript problem in the actual web app, but it might be because an API is getting really slow, or there's been some change to the backend. And so Polaris is all about incident detection, like letting you know that something's not quite right. When it comes to investigating why something's not quite right, that's where Polaris gets out of your way. And you'd still use a tool like Dynatrace or Datadog or Sentry or some other log aggregation tool to say, okay, Polaris is telling me that things are slow. Now let's go figure out why.
All right. I don't have any more questions, but there are no other ones that popped up. I do have a comment though. I noticed that you have Wingspan behind you, Mike. That's pretty cool. I think that's Wingspan. It looks like Wingspan art.
Yeah, got it. Then Castles of Mad King Ludwig.
That's a great one.
See the collection behind you too.
Yeah, that's one. That's what 6 shelves of board games that you can probably see. So there's a lot. Yeah. We're packing up because we're moving, but maybe you're gonna be at ng-conf. So maybe I'll bring some board games and we can all get down and play. I might bring Wingspan for us.
Oh, that'd be a blast. I'd love to play.
You've given us a lot of time back, Brian and Mike. You don't want to like go ahead and give your NGRX advanced RxJS to people who are online right now, or
you can come to ng-conf and we'll happily hang out with you all day and teach you RxJS.
All right, guys. Yeah, I mean that's it then. If you guys don't have anything else, any other questions? Last call for questions. If not, you guys get a whole hour back.
Brian and I will be set up at ng-conf. There'll be a Polaris booth. We'll have Polaris running. Right. And we'd be happy to talk to anyone who wants to stop on by, show you how to get started with it, give you some really cool stickers.
All right.
Cool.
Everybody have a great lunch.
All right. Thank you. See y'all.